Ever wondered how machines and industries work? Well, welcome to the world of machines, a fascinating realm where gears mesh, belts spin, and circuits buzz. It's a place where raw materials are transformed into the myriad products we use daily, from the car you drive to the phone in your pocket. This marvel is made possible by industrial automation, the heartbeat of modern manufacturing. In this intricate dance of machinery, efficiency is key. Imagine a symphony, each instrument playing its part, precisely timed to create a harmonious blend. This is the role of machines in industrial automation. They're the musicians, each performing their function at just the right moment. But who conducts this orchestra? Who ensures that every gear turns, every piston fires, every conveyor moves at the perfect time? The secret behind these machines is a system called Programmable Logic Controllers, or PLCs. Stay tuned as we delve into the world of PLCs, the unseen maestros of the industrial symphony. Meet Sam, an engineering student who is curious about how these machines work. A dedicated learner, Sam is always seeking to understand the world better. And today, the world of Programmable Logic Controllers, or PLCs, has caught his attention. Sam, like many of us, is fascinated by the complex dance of machinery that keeps our world running smoothly. He sees the movements of gears and levers, hears the hum of motors, and can't help but wonder, what's orchestrating this symphony of machines? The answer, he discovers, is PLCs. His curiosity piqued, Sam decides to delve deeper into the world of PLCs. He wants to understand what they are, how they work, and why they are so crucial in the realm of automation and control systems. He's determined to unlock the secrets of these unassuming boxes filled with circuits and code. With a backpack full of enthusiasm and curiosity, Sam sets off on his journey. Sam's first stop is at a factory where he learns about the basics of PLCs. So what exactly is a PLC? PLC stands for Programmable Logic Controller. Think of it as the brain of an automated industrial system. It's a type of industrial digital computer which has been ruggedized and adapted for the control of manufacturing processes. Imagine you're at an amusement park. You know those exciting roller coasters that start and stop at just the right moments, or the Ferris wheel that spins at a steady pace? That's all thanks to a PLC. It's like a director in a play, ensuring every actor, or in this case, machine part, plays its role at the right time. The basic structure of a PLC consists of four main components. First, we have the Central Processing Unit, or CPU, which is like the brain of the PLC. It's where all the data processing happens. Next up is the Input-Output, or I/O module, which is like the sensory organ of the PLC. It receives signals from input devices such as sensors and sends signals to output devices like motors or lights. Then there's the power supply, which is, you guessed it, the source of power for the PLC. Just like how we need food to function, a PLC needs power to operate. Finally, we have the programming device, which is used to input the desired instructions into the PLC. It's like giving a set of commands to a robot. Now, how does a PLC work? It follows a specific cycle known as the scan cycle. It starts by reading the input status, then it executes the user program, and finally it updates the output status. This cycle repeats continuously for as long as the PLC is in operation. Think of it like a diligent postman who checks his mailbox for letters, input, sorts them according to the addresses, processing, and then delivers them to the right houses, output. And he does this over and over again every day. With a basic understanding of PLCs, Sam is excited to delve deeper. Sam's next stop takes him inside a PLC where he explores its components. First up is the brain of the operation, the Central Processing Unit, or CPU for short. This is where all the magic happens. It's like the control center of a spaceship, interpreting and executing program instructions, performing calculations, and managing data. It's the CPU that makes the decisions based on the information it receives from the input-output modules. Then we have the I/O modules, the informants of the PLC. These modules are responsible for receiving and sending data between the PLC and the external devices. They act as the eyes and ears of the PLC, providing it with real-time information about the physical world. There are two types of I/O modules: the input modules that collect data from sensors and switches, and the output modules that send instructions to actuators and indicators. But what's a PLC without power? That's where the power supply comes in. This component converts the mains voltage into a lower voltage that the PLC can use. It's like the heart of the PLC, pumping life into the system and ensuring that all the components are up and running. It's important to note that while these are the main components, many PLCs also have additional features. These may include communication ports for networking, programming devices for changing instructions, and special I/O modules for specific tasks. All these components work together in perfect harmony to make the PLC a powerful tool in the world of automation. The CPU interprets the program instructions, the I/O modules provide the necessary data, and the power supply keeps the whole system running. It's like a well-conducted orchestra, with each instrument playing its part to create a beautiful symphony. Sam has now got a good understanding of the components of a PLC. Sam's journey now takes him to the world of PLC programming. In this realm, there are two primary languages that PLCs understand: ladder logic and function block diagrams. Let's delve into these languages and see how they control the operation of machines. First up, we have ladder logic. It's a graphical programming language that mimics circuit diagrams with rungs of logic. This makes it easier to understand for those with an electrical background. Each rung represents a specific operation, and the PLC executes these rungs one by one, from left to right and top to bottom. Each rung ends with an output, which can either be a physical output, like turning on a motor, or an internal output, like setting a flag. Now let's move on to function block diagrams, or FBD. This language is more structured and uses blocks to represent functions or operations. Each block has inputs and outputs, and the blocks are interconnected to create the control process. This language is best suited for complex systems where several operations might be happening concurrently. So, how do these programs control machines? Well, PLCs continuously scan and execute their program in a loop known as a scan cycle. During each scan cycle, the PLC first reads the status of all inputs, then it executes the program logic based on these inputs, and finally it updates the outputs accordingly. This cycle repeats over and over, allowing the PLC to control the machine in real time. For instance, in a conveyor belt system, the PLC might read an input from a sensor indicating that a box has reached the end of the belt. The PLC then executes the program logic, which might involve stopping the belt and activating a mechanical arm to move the box. After executing the logic, the PLC updates the outputs, causing the belt to stop and the arm to move. Sam is amazed at how a simple programming language can control complex machines. And just like Sam, we hope you too have developed a deeper understanding of how PLC programming works. After an enlightening journey, Sam is ready to return home. We've traveled a long way together, haven't we? From the vast world of machines to the intricate workings of Programmable Logic Controllers, or PLCs as we've come to know them. Sam, our animated friend, has been a keen explorer just like you. He's absorbed a wealth of information, and now it's time to reflect on the journey. Sam began with a simple understanding of machines, and then he was introduced to the magic of PLCs. He learned that PLCs are the brains behind many of the machines we see in our daily lives. They're the unseen heroes, making things happen behind the scenes in a precise and reliable way. He discovered that PLCs are composed of several key components. There's the central processing unit, or CPU, which is the heart of the PLC, making all the decisions. Then there are the inputs and outputs, the eyes and hands of the PLC, allowing it to sense the world around it and act accordingly. He also learned about the power supply, giving life to the PLC, and the communication ports, enabling the PLC to talk to other devices and systems. And let's not forget the programming device, the tool that allows us to give instructions to the PLC to tell it what to do and when to do it. Sam then delved into the world of PLC programming. He found out that programming a PLC is like creating a set of instructions, a recipe if you will, that the PLC follows to carry out its tasks. This process involves using a special language, often ladder logic, which is designed to be easily understood by engineers and technicians alike. With a deeper understanding of PLCs, Sam is excited to apply his knowledge in real-world applications. And it's the same for you too, right? Let's take this newfound knowledge and use it to make our world a more efficient, reliable, and exciting place to live. Did you enjoy Sam's journey into the world of PLCs as much as we did? If you found this journey informative and enlightening, give us a thumbs up. Your likes are a way of letting us know that we're on the right path, and they motivate us to create more educational content. Do you want to join Sam on more adventures? Then hit that subscribe button. We have a lot more content lined up for you, and subscribing ensures that you won't miss a thing. Remember, every like and subscribe fuels Sam's curiosity for more adventures. So whether you're a seasoned engineer, a curious student, or just someone who loves learning, your support matters. Stay curious, stay informed, and let's keep exploring the world of machines together.